our project partners Handoff today. My name's Gia Mancini.
I'm Louisa Silva.
And I'm Julia Heslin.
So we are the NASA-developed Western Europe Health and Air Quality team at Goddard Space Flight Center. So the project we've been working on for the past 10 weeks is focused on determining the feasibility of integrating citizen science data with NASA Earth observations into an interactive and open source map. So as most of you know, mosquitoes spread diseases such as Zika and malaria that kill over 1 million people each year. Due to rising temperatures, mosquitoes' suitable habitats are expanding, and mosquitoes are spreading into more temperate regions of the world to places like Western Europe. For this project, we partnered with the Global Mosquito Alert Consortium and all of its constituents, as well as the Institute for Global Environmental Strategies. So the main objective of our project was to lay the foundation for integrating multiple citizen science data sets and NASA Earth observations. Our ultimate goal is to help our partner organizations make information about vector and vector-borne illness more publicly accessible. So in order to accomplish this, we explored 3 different methods of integrating and displaying mosquito habitat suitability on an open source platform. We also overlaid the habitat suitability results with transportation, population, and public health data because these all have an impact on mosquito habitats. So our study area for this project is Western Europe. We utilized citizen science data that was collected and shared from partners in Belgium, Italy, Spain, and the Netherlands. So the citizen science data provided spanned from June 2016 to September 2017.
In order to create an interactive map, we utilize Google Earth Engine. Google Earth Engine allows users to easily access and call in NASA's environmental data sets. Citizen science data can be quickly uploaded to the platform as well. All analysis is completed through JavaScript coding and Google Earth Engine's code editor. Our goal is that this open source platform will provide citizens, researchers, and public health officials the capabilities to visualize and input their own data. During the last term of this project, we identified several environmental factors that influence mosquito life cycles and population dispersion. Those same factors were utilized in this project. These include elevation, humidity, land surface temperature, NDVI, precipitation, and soil moisture. The environmental data was gathered by Terra, Aqua MODIS, GPM, and SRTM. For this project, we also obtained citizen science data consisting of geographic coordinates of mosquito presence points throughout our study area. Using JavaScript code, we called in citizen science and environmental data onto Google Earth Engine. We took monthly averages of each environmental variable. The Maxent Habitat Suitability Model algorithm was then coded into Google Earth Engine and run for each month in the study period. This created monthly map layers showing the probability of mosquito presence. We chose Maxent because the model is known to perform well with many data sets. The output habitat suitability model implements only presence points, which was the type of citizen science data available to us. There were several options we used to implement the model onto Google Earth Engine. Option 1 involved hard-coding the Maxent model into Google Earth Engine from scratch. Option 2 coded Maxent's algorithm into Google Earth Engine using the model's monthly coefficient results. Option 3 uses Maxent's weights of each environmental variable on the citizen science data. Those values are run through a multinomial logistic regression and visualized in Google Earth Engine. Our habitat suitability model displays the probability of mosquito activity occurrence on a scale of 0 to 1. On the color spectrum, blue shows low mosquito likelihood and red shows high mosquito likelihood. The map is interactive, allowing users to set a specific date, turn on and off layers, and access map legends. After running our analysis, we found the model did perform well with all variables, resulting in an area under the curve of above 80%.
The Maxent model revealed some important relationships between mosquito presence and the environmental variables. As discussed in last term's project, NDVI and mosquito presence were positively correlated, meaning that homogeneous land cover and greenness was associated with mosquito presence points. Temperatures and mosquito presence were also positively correlated, meaning hotter temperatures were related to mosquito presence. Moisture characteristics like humidity and soil moisture were also positively correlated with mosquito presence. Elevation was also an important factor concerning mosquito presence. However, elevation values were inversely correlated with presence points. Finally, the distribution of the environmental variables' importance changed based on the season. For instance, elevation was important during winter months, while summer months saw a more even distribution of variable importance. There were some pros and cons to the different methods of implementing habitat suitability onto an open source platform. Option 1 consisted of hard-coding the Maxent algorithm into Google Earth Engine. This was a good method, but we needed an experienced programmer, and this would have essentially hosted the Maxent algorithm onto Google Earth Engine and made the model more interactive and user-friendly. With option 2, we explored implementing the results from the regression equation in Maxent onto Google Earth Engine. This method cannot be replicated for future months because the model's results would change. This would also not have been much different than running Maxent on the standalone platform. Option 3 was the best method for us. Implementing the environmental variable importance weights for each environmental variable can be easily understood by the user and replicated for future months' data. However, there were a few errors and uncertainties that came about from this project. While this interactive habitat suitability model is intended to serve as a foundation for work that can be done in the future, there was bias from citizen science data based on the population distribution of the study area. Some data sets included absence points, but not all. Thus, we could only use the presence points in our analysis. This is acceptable since Maxent assesses habitat suitability without absence data. Bias was also introduced after media events were hosted to encourage data collection. Interest in collecting these data may have spiked after media events, so the data may not have been consistent over time. People may lose interest in or forget about the app after having it for a while. Additionally, there was no distinction between the mosquito larvae and adults' mosquito presence points. So in our future work, how can we overcome these errors and uncertainties? We should encourage all citizen scientists to collect data on mosquito absence. This would broaden the options available for predicting habitat suitability. Citizen scientists from all countries should strive to include species distinction in its data collection. Many species have different preferences for environmental factors, and differentiating by species can help track certain types of diseases, since some mosquito species carry specific diseases. In the future, more data can be added to the model, such as minimum and maximum temperatures, inundation data, amongst others, and see how those variables interact with mosquito presence. We would also like to encourage other countries to input more data, as it would increase the accuracy of the model and provide a comprehensive analysis for the rest of the region. One way of reconciling the bias introduced from population-dense areas would be to encourage citizen scientists to collect data from remote locations to have a more stratified sample of the data. That being said, there should also be a set standard for the collection of citizen science data across all countries. In terms of implementing the model onto an open source platform, we could have explored other ways to host the interactive map. For instance, combining an R package with the Shiny apps might have had more flexibility of inputting a model such as Maxent. And we would also like to note that the Google Earth Engine tool that we've created will be available after going through the appropriate NASA software release process, which could take anywhere from 4 to 12 months. So in the meantime, we'd like to show some of the screenshots of a few capabilities of our tool. And this includes querying data by month, zooming into specific regions on the map, and then finally visualizing the habitat suitability. And so you can see here the different environmental variables that were incorporated into our model. And then finally, we would like to acknowledge all of our science advisors, project partners, and all of the people who made this project possible. Thank you.
Thank you, guys.
Any questions?
I have a question. I'm super excited about the Google engine with the, overlays, the ability to layer the data.
Mm-hmm.
Where's the precipitation data coming from?
It's from GPM.
Sweet, okay, good. And are most of the other parameters also NASA Earth observing satellite data sets? May 17th? Wow. Wow, unbelievable. I have just been going in and trying to mess with Giovanni and Worldview and trying in so many different ways to make it user-friendly.
Mm-hmm.
And it's so complicated, and so I'm really in awe. I would love to stop by maybe one day next week and have you guys maybe show me a little bit of this. And
Absolutely.
Yeah, we would love to.
Definitely.
thank you. Thank you.
Of course.
Quick question.
Yeah.
So this developed project obviously focused on mosquito monitoring and vector-borne disease, but the process of combining species presence data with
from a, I do some work on the disaster working group, and, they're always needing to find out right after a disaster who has been impacted. So one of the ways that they've been thinking of doing that, or that they have done that, is using the lights at night, because that gives an idea as far as electricity being out. But if you could take, say, for example, some of our landslide modeling, and then combine and correlate that with people who are actually there, have their cell phones, and then take pictures of the landslides and where they have occurred, and instantly know where to send them so that they can become a part of that model. There you've got your citizen science boots on the ground, and you've got your, computer layers, and then that would enable your first responders to respond so much more, rapidly.
Yeah, Facebook has a thing that you can check into when a disaster has happened so other people can know if you're okay. So maybe, another app like that you can check into and then also take photos. It has your location so it sees how close you are to, the event. So maybe that could be something that in the future.
And it could be too, for flooding, for landslides, for just a wide range, forest fires. As we hear on the news, it's always surprising that often these things are happening, but then they happen so fast. It's hard to know where the first responders need to go, to get to people right away. So, I could easily see that being a huge need. I also really like how you're looking at your parameters. Like, yesterday I was working with some of the expectations, the projections for the ways in which climate change is going to be impacting, and this was focused on the United States. Thank you. I believe it was the IPCC had gone through each state, and actually each country as well. I take that back. So it would be really fascinating, as from a public health perspective, to take all of these different countries to then project ahead, looking at the models, what the models are predicting, and then get some ideas about how that might impact various aspects of public health. Disease, water-related diseases like cholera or illnesses.
We did use some public health data as an overlaying layer on our tool. So we got data from ProMed and from the ECDC. So that is another layer compiled onto our tool.
So that's part of the Google Earth engine?
Yeah, it's one of the layers that you can switch on and off and then see where the trends are between, the habitat suitability model and all of the environmental factors, and then where outbreaks have actually occurred.
That's so cool. But you can't demo that right now, correct? Because of the software release?
We can
Okay,
send you
that's
photos
okay.
of it.
Yeah, we don't. Yeah, we
Yeah.
didn't have it in the presentation, but
Yeah.
we could take a picture of that layer for you.
My second question, could you say a little bit more about the need for a citizen science data standard?
Sure. Yeah. So in last term, I know you guys were sifting through the data sets, and the different countries had different inputs. So Netherlands included absence data, but the other countries had not. And some of them had included the amount of mosquitoes that were in a certain area. So that would be interesting if we were measuring mosquito abundance to determine the amount of mosquitoes that were in a certain area. So we just decided to go with presence because presence indicates whether or not there's a mosquito present. So setting a standard for each country would ease the process of implementing the data into a model and give us more options in terms of which model would be best to select from.
Another part about the sampling is that a lot of the data is somewhat skewed to largely populated areas because that's where the most reportings are going to happen. So the idea of a stratified sample where people can go out into remote areas and then report on presence could make the accuracy of the model increase.
Okay, my next question. On one of your slides, you put up a statistic that was something like 80% of the data is under the curve.
Yeah.
Could you talk a little bit about what that means?
Yeah, so the area under the curve is basically just how well the model performed. So the graph that we have shows the area under the curve of each month. So essentially it shows how well each monthly model performed. In some months it performed higher based on the environmental variables, and some months lower, possibly because of the season change. So we just wanted to have that figure in there to show you how the model performed throughout the year.
Is there a standard for what good performance is with models like this?
Not necessarily, but I think if you're under like a 70%, I think you just want to be as close to 100% as possible.
Victor can either answer that or ask a question.
Yeah, I think it's on. Okay, so yeah, I think like Louisa said, definitely above 70 is typically what you look for. But if you're less than 70, then okay, your model isn't running as great. So yeah, definitely want to keep it above there. And, not many models are going to be, not many accurate models are going to be, giving you over 95%, because there's just, with modeling, you can't really say that it's this is 100% accurate, because nothing really in a model can be like that. So yeah, definitely in between that 95 to 70% range, I would say is typically ideal.
Another interesting way to look at this would be to look at when people are reporting, well, it'd be more likely doctors, hospitals are reporting that people are showing up with illnesses that are mosquito-related, diseases. And I don't imagine that's going to happen as often in Western Europe, but certainly if you were to take this model and be looking more closely at South America or areas in Africa where these diseases are endemic, that would be really fascinating, to kind of compare and contrast where we're seeing the diseases show up, and then also where people are beginning to report the presence or absence of mosquitoes.
So ProMed kind of does that. They have researchers and scientists upload data when they witness exposure to an illness or there's one case. So when we were sifting through ProMed's data, there would be different points in Europe, and then one case of malaria sprung up here. So we brought that in as one of our layers.
We did try exploring hospital data, but there wasn't much in the way of Western Europe. So.
And that makes sense, and of course this is a start. But as we were to look ahead, I just think this is a really nice model, and I really like the fusing together of the environmental data parameters, and then also the citizen science data, and then pulling in that public health data as well. That has an awful lot of promise on such an easy interface.
Going off that, would you guys mind explaining kind of the process of incorporating the ProMed data and the ECDC data into the Google Earth Engine? Because if I'm correct me if I'm wrong, it's not just easily pulled through like the environmental data sets through Google Earth Engine, right?
Yeah, basically you upload it the same way that you do the citizen science data. So you extract the geocoordinates and perhaps the date, and then you upload it into a fusion table, which is essentially Google Earth Engine's version of an Excel spreadsheet. So it's the same layout, and then from that it gives you a specific ID that you can then call into the code editor, essentially.
And the ProMed data sets, they weren't actually geolocated. They had the specific city and country, so we had to go in and find the coordinates for each of those events and put it in the spreadsheet. So.
And so Google Earth Engine, as far as I'm aware, is always looking for suggestions onto different data sets that they could incorporate into their repositories. Obviously, Landsat, GPM, all these are already in there, but I think that if they were to incorporate with enough support any sort of public health data, then that could easily be brought in just as easy as all of these environmental variables were. While it's not difficult to bring in these external citizen science data sets and public health data sets, it is certainly not as easy as pulling in the environmental data sets, which is amazing about Google Earth Engine, can come up essentially instantly without having to download, go through the processes of downloading all those external data sets. So yeah, just wanted to clarify that part.
So I've very rudely been ignoring our project partners who are on WhatsApp right now. From the Netherlands, hi Anne, don't know whether you see this. Did they take into account that there is no elevation difference in the Netherlands? That's the first question.
Oh, well, it was taken into account in the model because elevation is run through, so no matter what elevation you have in the Netherlands, it'll be run into the model and still spit out a probability for that area.
Okay. Second question, and I'm curious about this as well. How did you deal with the difference in information provided by the different citizen science networks? Nuisance in the Netherlands and presence of I'm not going to try to pronounce that genus species name in Spain. This is very different data. So essentially the nuisance and the species presence.
So essentially, because none of the data sets were standardized, we could only really take out the geocoordinates of the presence data and the dates of the presence data. So until there is some type of standard, then all of the other, notes that they have, the amount of species, or the amount that they see, what kind of species, that we couldn't use. But in the future, if that does become standard, then that can definitely be used, especially the amount that you see and possibly the species.
So you just treated the nuisance data as presence data, essentially? Okay.
I know that with the Globe Observer Mosquito Habitat Mapper, with that app, they're taking pictures of potential mosquito breeding habitats, and then if they have access to either a microscope or a cell phone microscope, then they're able to identify at least three, the Aedes albopictus, the three of the species that are most likely to spread disease. That seems like that's a pretty systematic way of collecting data. And then it was also my understanding that in the future, we're looking at, we as in the scientific community and the citizen science community, looking at being able to fuse together a lot of these different data sets from the Global Mosquito Alert and something like Mosquito Habitat Mapper, and pull that all together into kind of a reservoir that would be available to at least to public health first responders to be able to get a feel for which types of mosquitoes are showing up where, even before they start to see the disease cases showing up in the hospitals.
Yeah, having the microscopes is a great idea on your cell phone, because until, we have something like that, then we don't know if the citizen scientists are really reporting on mosquitoes at all.
And yeah, the pictures like that would be a great, future work kind of addition as well. Because with those citizen science points, eventually what we would love to see is if those points were selected, if it would pull up the data that was associated with it, something like that. And again, this was really just a feasibility study to determine, how feasible is integrating all these citizen science data sets, and we see that it is, and obviously with more standardization, that would be excellent. And yeah, one of our wish list items was to have that kind of pinpoint. If you select a point, obviously it would pull up data on that specific point. But I think that's just something for future considerations for sure. Things like that to incorporate those photos, because I know there are some excellent photos from all the different citizen science data sets that were provided, and they just we couldn't incorporate them in our limited time frame.
Emerging.
That's right.
So I'm not that familiar with Google Earth Engine. So when you go to the engine, can you download data? Can you do certain queries and then?
Yeah, so it looks just like a Google search bar.
Okay.
You can just search whatever data set you want, and then either call it in. You can download it separately.
Yeah, so you can either host it on the Google Earth Engine interface or export it to your drive and use it as a standalone in standalone platforms and stuff like that.
And what kind of metadata documentation do you have in terms of where the initial data points came from? So I'm anticipating that it would be possible to, and this is just me not understanding Google Earth Engine, download, for example, a section of Europe that is between Spain and Italy that would include data from 2 of the citizen science projects. What sorts of documentation on those data points would be available in the metadata?
So you're saying you want to download the citizen science data points within those 2 regions, or the
Yeah, as one
environmental?
example.
Okay.
Is that something that would be possible, or?
I am not sure if it has extensive metadata associated with it. When we downloaded the environmental variables, there weren't there wasn't a metadata file that came with it. So
I think that you can export the different fusion tables if you wanted to look at the monthly mosquito presence points.
And would that say what project the different data points came from? Or is it all treated as one once it's in the Google Earth Engine?
Oh, well, we uploaded it as one.
Yeah. Okay.
But we still have the separate data sets if you'd like to see them.
Just curious.
yeah.
I have another question. This is often asked, usually asked after an investigation is done. For each of you, what, if in the best of all possible worlds, you were able to, you had this funding and you had the ability to take one aspect of what you've learned from your study and move it forward, what would each of you do?
I think creating more awareness about citizen science and like getting people out there and getting involved, because it's very helpful. It's sort of like a check, like we have this satellite data, but it's sort of confirmation on the ground, and you can use them together to create something like this and create public awareness.
Yeah, I agree as well, because then that'll just get more points for the model, and then that'll just create a better accuracy, like overall for the model in general.
Yeah, and I think having scientists and researchers like go through these data points and like check and make sure like that what's being reported is a mosquito, and I know like some of the data sets do that just to verify that those mosquito outbreaks are happening and that sort of thing. And it'd be cool to have it like sort of live instead of having it so like we had to upload it like past data into Google Earth Engine, but somehow including like somehow actively inputting data as it's happening would be pretty cool to see.
What would that look like? Would that be a series of APIs or?
Oh, I'm not sure. I'm not sure.
Victor's nodding.
Yeah, that absolutely would. Kind of incorporating that, an API into the Google Earth Engine, I think, would be the way that you'd go about doing that. And the Google Earth Engine itself is an API. It's certainly possible. Would need extensive programming, obviously, but that was, one of our initial goals was to be able to actively update with incoming citizen science data sets and new environmental data sets. That was absolutely one of our goals, and we would love to see, further work being done on that. So if anybody, is willing to support something like that, then that's what we would like to see.
Yeah, we'd really like to move that forward as well.
I'm thinking with the Globe Programs app, when people enter the data, it's all geolocated, and you can see it show up on the Globe, website, the data visualization tool, and then you can overlay that with some of the different, Earth observation satellite data. So that might even be a place, to look at to get a sense of one of the ways in which using one of these citizen science apps, it's already being done. And I love the fact that you said one of the important things is getting the public involved and invested. I know as you were talking, you also mentioned that you want to make sure people remember to use the app. That's one of the challenges we find in working with the Globe Observer app is, to get people at making it just a habit, a part of what they're normally doing to be out there and collecting this data. Any suggestions for how we might be able to engage and keep the engagement level going with the general public? Because while it's one thing and it's important to look at clouds and better understand weather, understanding where these diseases are going to show up, is huge. And the ways in which the public can actively be involved in decreasing the potential mosquito breeding habitats is like the most vital way to stop the spread of these disease.
So I had previously worked with the Maryland Geographic Alliance, and one of their initiatives was called like BioBlitzes. So students, elementary and middle school would go out and use this app called iNaturalist and like record different species. And like the goal was to just like record as many species as they could like in that certain area. So I think like involving schools and even like college students for like extra credit or something, like going out and recording these data would be a good way of implementing that.
Any idea of some valuable feedback that the science community can provide to the citizen scientists to show them that the data that they're collecting is meaningful and valid and worth their putting that as a part of their regular routine?
I think just like utilizing it like we have is a good way of validating like citizen science data. So
Being able to visualize it with things that are influencing it, I think is a really great way to see that your data is actually going to something important.
I think that's a great question. Noting again, the Netherlands also believe that it demonstrates the importance of having more continuous reporting by our observers, preferably standardized in the different networks. So thank you for making that explicit. This actually relates to my research, what we're discussing. I did my PhD on motivation in citizen science. That was one component of it. And research shows that many of the things that you're discussing, like giving feedback to volunteers, like using visualization so that they can see where their information is, et cetera, is indeed motivating. But as we take this project forward, and I really hope to keep working on this even after the Develop Handoff, I think it would be really interesting to not only make progress on the data integration, but also to do a research project around different interventions that the projects could potentially use and push to their volunteers, and actually empirically test out whether or not, you know, if you send a push notification every week saying, please upload your data, if that works, if gamification is something else that different citizen science projects are experimenting with, if that can be an effective mechanism for motivating, and so on and so forth. Along that line, we have a question from WhatsApp. Is Google involved in the Develop projects to any significant degree? Is this something that they would continue to support moving forward?
So I mean, like, Google wasn't actively, I mean, they weren't involved in this project. We just used their platform. But the reason we chose Google Earth Engine was because a lot of NASA Earth observations are hosted on that.
So it's a good fit for NASA.
Yeah.
Definitely. I know that there's definitely a push within NASA to incorporate more Google Earth Engine, use, because it is open source. I mean, that's the greatest part of it. It allows many different users to pull in so many different varieties of data sets, and from no matter where you are, if you have the internet connection, you can do it. You don't need to, have an insane amount of bandwidth or computing power to do what the Google Earth Engine can do, and that's the great part about it.
I think I have a really good comment to close on. Citizens will like it very much if their observations will be used in these kinds of projects. Working together with NASA in itself is motivating for people.
And that's great. And I would really just like to say thank you to everybody who joined remotely as well, and everybody who joined here today. Thanks for supporting the teams throughout this term and last term as well. It was really a pleasure working with everybody, those in-house and those also joining remotely again. So thank you, and we really hope to continue all communication and working with each other. So we really appreciate it.
Thank you. This is fantastic.
Yeah, thank
I'm
you so
really
much.
impressed with everything that you've been able to achieve this semester.
And to look at where it left off, at the end of the other semester, which was great. I mean, it was just what they had done, what you had been able to accomplish was wonderful. But now to see how far it's come with these overlays and the ease of being able to look at this data, it really is tremendous. You are to just be hugely congratulated.
Thank you so
much. Such a short amount of time.
It was short.
It was short.
Yeah.
Okay. Thank you so much.